Well, hey, Trevor, welcome to the podcast. I'm so super excited to have you. And, for most people that may not know your background and our connection, I will just say that, we grew up in East Texas. We went to SFA forestry school. We shared an office in the masters. Like, as I was telling you earlier, there's nobody more similar in this, professional world to me than you, at least until we hit our PhDs and took our separate paths. But again, super excited to have a conversation with you today, and thanks for joining me.
Yeah, I'm super glad to be here. We can catch up some.
Yeah. Well, and it's been a while. It's the whole pandemic thing, and then people stopped seeing each other, and then we finally figured out we could use Teams not just for work. We could actually start catching up, with people that we haven't seen in a while. So it's been actually great, I think, in that part, just to be able to look at each other's faces and go, "Hey, how you doing? Been a long time."
Yeah, definitely makes a better connection and a chance to kind of relive some nostalgia.
Right, exactly. So, I want to get in a little bit later into your whole connection in the biometrics world. I have to tell you, I'm so excited to see what you've done, first of all, in terms of your accomplishments. But I'm also really happy to have a biometrician in a genetics position, because I think that's been, there's been a gap there that we haven't been connecting. And it's nice to see that. And just from the conversations that you and I have had the past couple of years, it's been interesting to see a different take on it.
Yeah, definitely. That has been somewhat of a niche. So I'm really not very good at biometrics, and I'm also not very good at genetics.
Yeah.
But knowing a little bit about both has been really well for me.
Yeah. That's interesting how you say that. I know a lot of biometricians that might say that they're not good at biometrics. So
Yeah.
I've seen some of your work, and you do a pretty good job. So
It's such a diverse field. Sorry to interrupt. It's just such a diverse field. Like, no one can be the expert at everything, but those that uh, have dabbled in everything are really the ones that we have the highest regard for.
right. And generally, those are the ones that have, put in a career at this, because it's just so hard to be a master of all things biometrics. I mean, if you think of all the different ways that we model forest and all the different types of forest and at the different resolutions of those data, there's just so much there to do. And you don't get that in an early career. It takes you a lifetime to accomplish all of that.
Yeah, definitely. Thinking about all the different methods and
Mm.
also the locales, how different regions that you practice in shape how
Right.
you might go about a modeling problem, the history, the type of data that's been collected, the type of analyses that are needed. It's so diverse. It just blows my mind.
Hmm. Same here. And, you know, it's, and then we always try to do our best in those regions to put things together. But the biggest thing is, if it's outside of the big names, loblolly pine, Doug fir, those kind of things, then the data available for modeling tends to be much, much smaller. And so
Yeah.
I'm thinking of, like, for example, bottomland hardwoods in the Southeast US right now. I mean, I guess with FIA data, that's a big data set, but a true, permanent plot study of growth in bottomland hardwoods, like, there are very few, and it's usually of this, this type or that type, and then you can't extrapolate that to other regions. So it just makes modeling those timber types really complicated.
Yeah.
And that's important now because of, I will say it, and we always say it, carbon. Now everybody's interested in carbon, and do I have a carbon project? And then it's like, okay, well, now we need to estimate the carbon. And I guess there we're fortunate that we have FIA and FVS.
Yeah, I mean, it can be a wonderful resource if you're just comfortable with the scale of it.
Right, right. And that's the important thing to say there, the scale of it.
Yeah.
Yeah. So I want to take us back a little bit, though, because while I know your history well, most people don't. So tell me, how did you get into forestry?
Oh gosh, yeah, that's a great question, and I know every forester that you ask um, has a unique question, but a lot of times it's a similar or a unique answer, but a lot of times it's similar. I grew up on a tree farm, and I love being outside. I spent a lot of times riding around a golf cart
Mm,
down woods roads and pushing over dead snags and trying to like dam up a stream, a little stream, ephemeral stream with sticks and branches. And all those things just really stuck with me. And when I got to college, I didn't have a career picked out. I was walking by the forestry building at Stephen F. Austin on the first day. And I said, that sounds cool. I had no
mm,
idea. I didn't even really comprehend the logging industry, the forest products industry, how important wood is to our everyday lives. I just didn't have a career path picked, and I said, I like being outside. This might
mm.
be a good one. One thing that I've always liked about forests um, is that they're easy to hide in.
Yeah.
I mean, you can just walk 15 feet into the woods off of a busy highway, and no one will know you're there. And you can just disappear. And
Mm.
something about that has always added mystique and but also comfort. You know, if you ever just need to get away, you can just go into the woods, disappear for a moment.
Yeah, for sure. And I can't cite any exact studies, but at least I've seen a few that show a correlation between being in the forest with well-being. So just not just going and getting lost in the solitude, but the fact that you just go there and you get some kind of positive energy out of that, and it just makes you feel good. I don't know about you, but I spend a lot of times in the woods with my kid, just walking around, looking at things and just enjoying that time because it's just like refilling the battery.
Absolutely. And I sort of feel compelled to drag my kids into the woods and
Right.
try to pass that on. Another thing that I would say has really kept me engaged with forestry. So that's what first attracted me to it. But something that's kept me engaged has been this idea of farming the woods.
Mm.
And, if I think of, and I don't want to get in trouble with the agronomy folks, but me personally, if I think about a maize farm or some other row crop, it's just it seems a little bit boring just because it's so efficient. And we strive for efficiency in forestry, right? We want uniform plantations, great survival. We want the trees to look similar and because it's just more efficient. But they're still trees, they're still wild, they're non-domesticated. The system is messy. We work on marginal land.
Mm.
Um, so it's like a almost a frontier that
Hmm.
that I have derived a lot of satisfaction, trying to increase the efficiencies because there's so much work to be done. Unfortunately, though, it feels like when we're done, it's going to be boring, like economic crops.
Well, I don't know that we'll ever be done, and it's the things that the type of things that you're working on. It's like we are always trying to perfect a system, but we're also kind of one generation behind, right? Because with new genetics and new technology, it seems like there's always some kind of improvement, whether it's to growth or disease resistance or whatever. So it feels like we're always moving that forward. And maybe the agronomy folks would say the same thing.
Yeah, definitely. They it all depends on it's all relative.
Right.
One thing I do though know is, as we do make it more efficient, we're going to free up the strain on those natural forests. We're gonna have more luxury to keep those and just not have to manage certain lands as intensively.
Right.
And those are the forests that we love, right?
Right, exactly. And well, I do love a pine plantation. There's something about being in a pine plantation, especially with like a nice clean understory that you could just walk for days. Like it's just something about that that is tranquil to me. But um, that's interesting you say that. And, we're always going to need forestry. We're always going to need wood products of some form or another. I heard from, I think it was one of the Arborgen guys who said that, you touch every day like 5,000 things that
Yeah.
are made from a forest product, mostly from cellulose. But, and that is just so wild to me how widespread the use of forest products are. And it makes you think like we're always going to need that. So if we can improve those plantation processes to produce the most that they can while maintaining some kind of ecosystem services, and as you said, free up our natural forests to just be natural forests, that would be like the end goal, right?
Yeah, I mean that's where like I find the energy to come to work every day and
Yeah,
give it my all, because I know that we have this community that we're a part of, and we are getting closer and closer to that. And
yeah,
if we stop working on it, it's we know the route that it could take.
right, exactly. But I think we're very similar in a way that we're problem solvers. We like to get new problems and figure them out. And it actually is sometimes nice whenever there's a little data, because it makes it more complicated to put the pieces together. Um, and so I get what you're saying. And I will add to that, just to come in and to be able to work with different individuals, like who have different goals in mind. While they're all using kind of the same resources, they have a different end goal for themselves personally. And me, the fun part is also getting to interact with those people and sometimes get a different perspective about why I'm doing what I'm doing.
Definitely, I will say that one thing that really pushed me towards studying forest biometrics is so I have been inclined towards math. I did well in my math classes in high school, but didn't really know what the purpose of it was. Like, y equals mx plus b. Why would I need to know that? Um, but whenever I saw Dr. Coble applying in my forestry biometrics 200 level course, my second semester at SFA, when I saw him applying these stringent mathematical functions and mathematical rules to these wild forests that are incredibly variable, but still sort of deriving some knowledge out of it, that's what really clicked for me. And that's whenever I sort of really hit the books and kicked it into high gear and said I want to know a lot more about this. And that problem solving, taking something that's messy and like forestry data.
Mm,
We complain about how messy it is, but we also kind of like how messy it is. Like
right.
that variability is what we want to. Our problem solver kicks in and says, "Hey, we want to try to model this variability and see what can we learn from it? What sort of on average, what's going on, and then how much certainty do I have in that average um, prediction?" And that really got my gears going.
Right, exactly. I think a good analogy is like a 12-piece puzzle versus a 1,000-piece puzzle. Like, it's nice to put together the 12-piece puzzle with your kids, and maybe there's some analogy to teaching there. But you don't like to do that day to day. But if you're a puzzle person, like 1,000-piece or a 10,000-piece, like you want to have the more complicated problems, because that's what's more challenging and more rewarding at the end.
Definitely. Yeah. And it's really nice to be able to come to a data set um, with a set of tools and try to put that puzzle together
Right.
and get something pretty out of it.
Right. Or to realize that the set of tools that you're used to using don't work and you got to go get a new tool. Right.
Yeah. Or more data.
Yeah. I was thinking back to your master's work, where you were examining some tip moth damages or well, you were doing a like growth response with tip moth damages, something like that. And I remember you went like head over heels into mixed models, and I at that point had no clue what a mixed model even was. Um, and so you saw an opportunity to use a new tool and you went after it. And I think that's awesome.
Yeah, and that still, I think it was last week, I was Googling how to model this thing we measure on trees. It's called sweep. It's
Mm,
basically in our progeny test, we modeled it, or we have been measuring, don't always measure it, but some cases measure the deviation from straightness. We call it sweep. And it doesn't have a normal distribution. Where
mm,
you have is a lot of trees have like zero sweep or maybe a half inch of sweep. And then it tails off, and eventually you'll just have a few trees with like 4, 5, 6 inches of sweep. So I've been thinking, what sort of distributions can we use to model that? And so I started looking at the gamma distribution, and it's a continuous distribution. It's right skewed, but it can't take zeros.
mm-hmm.
So that doesn't work. And so I started Googling how to get around this. And that's what really keeps bringing me back, is how do we model this messy data with some new techniques. And
Right.
sometimes you just got to do it simple, because and a lot of times what's simple is just as effective,
Mm.
but it's also fun to branch out and try something that you haven't tried before.
Can you shift the distribution right by one?
Yeah, that's what was the common solution I came up with,
Yeah.
and it's like, that doesn't feel right, but
Right.
it works.
It
It's
works.
hard
It
to
works.
argue with that.
Well, going back a little bit, you did decide, I think, a little bit early on in your bachelor's degree to go for a master's, right? I mean, I remember you and I were like the only two taking statistics courses as electives while everyone else was doing bass fishing.
Yeah, that's a good observation.
Yeah. But so you had an idea from early on that you were going to go and at least into a master's, right?
I mean, Mickey, it was probably a real similar story for you, right? We saw Dr. Coble so happy
Yeah,
teaching that forest biometrics class. We saw we've said we want to be like that. We want to be
right.
like this guy.
Exactly.
And I still strive to be, to model after Dr. Coble, just because he's the most genuine person I've ever met.
Mm,
He's incredibly passionate about what he works on. He's a great teacher.
yeah.
And whenever you're young and you don't really know what you want to do, sometimes you flock more towards people that you want to be like.
Mm,
And I think that was a big part of it there. And also, we graduated at a tough time for forestry with 2008,
right.
aftermath. And, we kind of knew we were going to have to move to get a job out of the East Texas area if we wanted to be doing data things. And, one thing I can remember taking statistics courses at Stephen F. Austin, really small classes, like maybe 10 people at the most. And thinking like, statistics, data analysis, these things are cool, they're fun, but at the end of the day, most decision makers are just going to go with their gut. All
Right.
right, they're going to make a choice based on how they feel. And year after year, that I think that's been proven, that sentiment has gone away from that, as a society, been producing more and more data. More and more folks recognize the value of extracting objective information from data. And I would never say that now, right?
Right.
And I don't think a college freshman, a sophomore student taking stats classes would say that now. I think they'd recognize very quickly how important it is to be able to analyze data.
Right. And I think we're seeing uh, not as many people are as interested as analytics, at least coming out of the undergrad. And I don't know why that is. If maybe there's just been a shift to other things, or maybe us analysts are too often in our caves and not going to the career fairs and saying, "Hey, this is an actual career and it's very rewarding," or what they may be. But at least I've in the past couple of years, I've heard of people hiring and just going like, "Hey, where are the Georgia kids want to stay in Georgia and the Texas kids want to stay in Texas. And then, how do we get people to, move out of those areas?" And yeah.
I think the answer is just like Dr. Coble did for us, right? We just got to put ourselves in front of these early career or students
Mm-hmm.
and let them know that, hey, like this is a lot of fun
Right.
and we need help and there's work to be done.
Well, and I don't know about you, but for me, it was a bit misleading because I did model a lot of my career path on what Dr. Coble was doing. And so I thought, like, I'm going to be able to teach, interact with students. I'm going to spend all my summers in the field collecting data. And, like, after a certain point, they just don't let us go to the forest anymore. We're just stuck behind a desk. So it was I went in with all of those motivations of I'm going to get to be in the field, and I'm going to get to see a lot of different trees and different forest types, and then it just doesn't happen.
That's what happens when you're good at your job, right? That's all they
Right.
let you do.
Exactly. But I try to get out at least once a month and go see something new. Like, it's just and with the idea being that how can I ever model a forest if I don't know what it looks like? I
You got
mean,
to see it.
right? Ones and zeros are kind of meaningless unless you're actually knowing what those numbers mean. So,
For sure.
yeah. But, and then, so did you plan after your master's, did you plan to go for a PhD, or did you just want to get to work?
No, yeah, I after I got my master's, I wanted to get to work
Yeah.
because I did not have a smooth master's experience. Being
Okay.
totally honest, it was really difficult for me to do that. And like whenever you tell a high school student they're going to college, you say, hey, get ready because it's a lot harder than high school. The teachers don't hold your hand. Same thing when you go from an undergraduate to a graduate student. They don't hold your hand. And I didn't really have the temperament to sit down and read journal articles at that time like I should have.
Yeah.
Um, the project that I worked on, it was a real world project. It was looking at the effects of protecting pine plantations from titmoth, young pine plantations, and then measured through about 8 years. So it was a real world data set, and that means it was messy and it required a lot of cleaning. I don't like the term data cleaning too much because it's
Hmm.
not really dirty. It's more
Yeah.
like maybe data polishing or organization.
Yeah.
But I didn't realize how much time that would be, um, and then when it came to the modeling, there was it all the things that I told you I love about biometrics, the challenge. At that time, I wasn't. It was a lot for me, and so I struggled with it. I did, I got the master's done, but it kind of left a sour taste in my mouth. So I said, "Hey, I want to go to work," and I, I, the only job I could find that was in forest data analysis was an inventory analyst job
Mm.
with Hancock Forest Management in Charlotte. So I made the move to North Carolina. And I don't want to say that was the only job I could find. It's just that was it was a really great opportunity. And honestly, I was kind of excited about moving
Mm.
and seeing a new part of the world and trying something different.
Yeah, that is a bit exciting to finally have that moment where you spend your entire life in like a 30-mile radius, and then you're like, oh, now I get to go on an adventure, right? I get to go up
Yes.
to, for you it was North Carolina, for me it was Virginia, and like going and seeing something completely new and different. And while the lifestyle is a little bit similar, it's an adventure. And so it was fun.
Absolutely.
Yeah.
I was married at the time. My son was about 6 years old, and it we you really hit the nail on the head. We'd always been in the East Texas community, and it felt like going on an adventure, and it really brought us all closer together as a family. And
Mhm.
we were really really happy.
Yeah, that's awesome. And you spent how many years was it before you decided to go back for a PhD?
I worked for 2 years with Hancock Forest Management, and I learned a lot at that time. And I really enjoyed working with my team at the resource support group in Charlotte. I had a really good boss, Jim Boyd. He taught me a lot about inventory data, that like the practicalities of contracting timber cruises, getting QA QC, the data that's coming in, and then organizing that onto a SQL database. And I learned SQL code, and that has proved to be incredibly effective in my career. And it was one of those things I learned from necessity. You got all this data, it's got to be organized, and the efficiency of using a database. So now whenever someone sends me an Excel spreadsheet, an example in an email, and they say, "Hey, I attached the database," I mean, I just scoff. I'm like, "This is not
right.
This is a data set. It's not a database."
Right.
But I learned a lot there. I really enjoyed the people I worked with. I had a colleague, Denise Bonnet. They hired both of us at the exact same time for the exact same position. And so we were like teammates, and we would tackle projects together, and then do our own like side projects. But it was just a really good working environment, a good company culture. And the reason why I left was because I'm reading these journal articles about different things like thinning response and modeling different things, and I'm using those. I'm taking those coefficients, using them in my day-to-day work. But I wanted to be the guy that was making those things. Producing that research, and it was incredibly satisfying to apply those things and important. But I wanted to be on the other end. And so I started looking at, also, I wanted to be better at statistics. I wanted to know more about the field of statistics, and I wanted to be better at math. So I was interested in going back to university, and I knew that NC State University had a renowned statistics program. Unfortunately, I probably could not meet the qualifications to get into that program, but I saw an advertisement for quantitative forest genetics Ph.D. assistantship, and I knew I could get into a forestry program.
Right.
So I reached out. Dr. Fikret Isik ended up being my major advisor, was advertising for a Ph.D. student and analyzing breeding program data from the loblolly pine breeding program there at NC State. And so I reached out to him, and drove to Raleigh, met him at a coffee shop, and it just clicked. I thought it was interesting. I didn't know anything about it, had never taken a genetics course. In fact, my first genetics course was my first semester there at NC State. But yeah, I just it clicked, and I thought I was gonna like double major in forestry and statistics, but the truth is that just between the matrix algebra and the theorems, I couldn't. It was too much for me. So I kind of said, maybe this isn't the way that you can best add value to the world. Maybe you should do other things that you're more that you can do pretty well. Quit trying to do this thing that you're not excelling at.
Yeah, I think I had a similar experience. I think most PhD biometricians generally do a master's degree in statistics. So I'll take a step back to what you're talking about. Why did I get into this? Why was I taking stats courses as electives in the undergrad? Because I wanted to be a better biometrician. And where it clicked for me was watching, as you said, watching Dean Coble work through these algorithms and show why they are useful. Whenever I got into the master's program in statistics at Virginia Tech, it was, again, all theory. And then it's like, I am in my 5th linear modeling class. And I'm going like, how many times do I need to show the how to estimate the parameters of a linear model? Like, seriously. And so I got about halfway through and I told my advisor, Harold Burkhart, like, I'm done. Can I just take applied courses? Because I want to learn all these tools. I want to use them, but I'm not ever going to be the guy that's coming up with like the newest, best algorithm for modeling, mixed models or something, but I want to be able to take those new ideas and apply them in forestry. And that's something that I'm good at. So probably similar to you, it's just like, oh,
Absolutely.
do I have to prove another theorem? Like somebody's done this 50 times.
At some point I found that, I was better at applying them than
Right.
coming up with them, and just run with it.
And I'm happy for all those people that like to do that. I mean, more power to you. We definitely need those kind of people in forestry because that's how we're advancing some of our, modeling. But it's just not me. That's not what I want to do. It's not what makes me happy.
So that's how I ended up at the working on a PhD towards forest genetics.
Yeah, that's awesome. I mean, and I guess the shift from Charlotte to Raleigh is not so huge. But by then, did you had more kids, right? So you started a PhD with two or three?
Yeah, two
Yeah,
young children, and it it's a lot. But the kids, yeah, they take away a lot of your energy, but they also give you energy.
yeah,
They give you a reason to focus. They give you, in fact, yeah. There's no telling if I hadn't had kids at an early age. There's no telling what I would be doing.
right.
I'd probably be way less focused.
Yeah, I think maybe that statement works for a 25 to 28-year-old whenever you're 38. I don't know necessarily that you would say kids give you energy, but they definitely
Yeah,
give happiness.
that's true. That's true.
uh,
It took me a long time to do my PhD. I worked on it for 7 years.
yeah,
7 years. I was working full time with the co-op. They had an opening for a tree improvement manager, and this particular opening sort of coincided whenever I took that job. It was in my it was actually just my second semester working on my PhD. So I had less time to focus on those statistics courses, those harder statistics courses, the more theoretical. And I that's kind of when I said, hey, you're going to be someone that applies these things, not someone that develops these things.
I also took about 6 years to finish my PhD, but in a little bit in my defense, I had a project that was funded, and after 2 years, the funding went away. Just was, I don't want to
Yeah.
mention the details there, but it did involve the NC State Forest Service. But
Oh.
then I'm going, okay, like I was depending on that funding to get data for a project, and now that's gone. So I basically like I had 2 years that were just wiped away, and I had to start over. And so then I had to come up with a new project, and oh boy, did I put my whole life into that project. And yeah, then took another 4 years to finish up. But I think it's okay though. It's good to get in there and have that experience. And I definitely learned a lot. Of course, people that do it in 3 years also learn a lot, but you don't have the same experience.
I you know I don't know that I have as good of an excuse. I really was a little bit scatterbrained
Mm.
and, focus on a lot of different things. And my son told me this saying: if you wait to if you wait to the last minute, it only takes a minute to do whatever you're waiting to do. And that's not it doesn't apply 100%, but for some of this, I was procrastinating a little bit. But I was having fun,
Yeah.
and that pressure to finish quickly wasn't there, and because I was working full time, and I wasn't depending on the PhD as my funding source, because I was also working for the group that I was doing my PhD with,
Mhm.
and I took my time, but I was learning a lot, and I really enjoyed it. But at some point, it was like, hey, you just got to finish this thing up, and that's what
Right.
really set it off for me. Is I was I had too high of a standard of what I thought was acceptable.
Mhm.
And now that I'm advising PhD students and master students as assistant professor, I'm trying to really manage what I want to keep really high standards, but also I don't want to hold these, early career professionals back.
Right.
And it shouldn't take 7 years, but there's no judgment if it does take longer than that.
Yeah. I, and I don't know how you are, but my advisor was at the, late stages of his career. So he didn't need to he wasn't trying to get tenure. He was already university endowed professor, distinguished professor. So he didn't push too much, and he let me run wild with like these crazy ideas. He was like, yeah, go for it. That's where we're going to find out new information. And so I was just like, constantly in left field going, let's try this, let's try that. And it was funny because sometimes I would do those things and I would come back. It's like, hey, this didn't work out. He'd pull out a student's report from like the 70s going, well, my student back in 72 tried this also, and it also didn't work out, but that's okay. Maybe next time.
It terrifies me being the advisor of grad students because you're kind of at a point, their early career, and those years really count. Early
Right.
career, and I want to make sure that I don't basically screw up their career. So that's finding that balance of something of exploring, but versus focus. It's going to be that I'm just going to have to do my best to navigate that.
Right. I think it can be hard, but the fact that you're actually thinking about it shows how good of an advisor that you are, because how many don't think about it and they're just like, pump out papers for me,
Yeah.
back the whip and get after it. And, I see it also in my wife, who is a professor of chemistry. She's always just trying to do the things for the students and trying to help them have a good career. And I recognize that also in my advisor, in Harold Burkhart, also, that's what he did. He knew that everybody was different and everybody had a different pace and everybody had different needs. And once you recognize that and you want them to succeed, I think that's actually going to help you succeed.
Oh man, it's easier said than done.
Right. I guess, I'm not in that situation. I obviously took a much different career path going into consulting, but, I think while it might be terrifying, the fact that you're there and willing to put in the work, I think any student should be grateful to have an advisor like that.
Choice of advisor is such a critical thing for a student. And the thing is, it's just like when you start a new job or you're hiring a new employee, you're trying to figure out, hey, is this going to be a good fit?
Mm-hmm.
And you really don't know until you spent a year with the person working on a project. And yeah, that's tough, especially for a student, because usually they're giving up everything to study this, to do this PhD project. They're hitting pause and everything else. So yeah, it can be daunting. It can be scary.
What we talked about earlier about, there kind of being a lack of students wanting to go from an undergraduate program into a master's program in analytics. What we have now is a lot of international students coming over. So not only are they giving up everything to go into a program, they're also moving countries, which,
Yeah.
and sometimes, using their second or third or fourth language is English. And then how challenging must that be? And how, just kind of terrifying is that to, give up not only the life that you have and the path that you could have, but moving countries entirely. Like, that's terrifying.
Academia is it's kind of weird.
Yeah, right.
It really is.
Well, so you went and you worked on your program there. You finished up your PhD, and I guess, like you said, the entire time you were working as the research. Basically, you were managing and coordinating measurements. Yeah.
Yeah, the measurements, the planting a progeny test, but also the breeding plan, coming up with the list of trees to cross,
Cool.
and also consulting with members, showing them how to use the results from the analyses.
Yeah.
And basically, it was like a breeding program research coordinator type position.
Mhm.
So, and then also, working on like novel research for my PhD at the same
Right.
time. So,
Right.
I mean, it was by far the best job I've ever had. It was amazing because I could drill down and focus on a problem. I still had the day-to-day things, making sure that the seed gets extracted from the cones. Well, make sure the right cones get picked, seeds extracted, they get into the inventory, then choosing the families that get planted out in the tests, making sure that the measurements are coming in, analyzing data as part of the program, and reporting the results to the members, making sure that that technology gets transferred. It's a really good job, and I'm really excited to announce that we so I did that, and then the assistant professor for co-director of the program came open, and naturally I applied for that. But I've been doing it. It took us a whole year to replace me
Yeah.
doing that position, so I've been kind of doing both for the last year, and I'm really happy to announce that last week our replacement, her name's Ms. Carla Castro, has started that position, and I'm excited that she's going to start doing those things because I know how fun of a job it is. But some of the things I'm kind of reluctant to give up because I'm
Yeah.
like, well, I was always the one that came up with the breeding plan, and you
Right.
got to let others carry the torch at some point.
Yeah, I saw that post on LinkedIn. It's really exciting to have somebody new coming in. I also have somebody new coming in to work under me starting in February of next year. And like you said, like I'm a little bit reluctant. It's like, okay, I know I need to give these things up, but I don't want to. I like doing it, but I need to give it up so I can focus on other things.
Yeah, that's again, you just keep getting pushed farther and farther from the woods that you love, right?
Right, exactly. Until eventually you're just an administrator.
Oh man, not looking forward to that. That is the way the road goes.
Right? Do you have any aspirations to be a department head or a dean or any of that?
I, it's a wonder that I didn't have aspirations to be where I am now.
Yeah.
It's just sort of just kind of just worked hard on the problem at hand, and this is kind of where it took me.
Yeah. Yeah. So, when you applied for the position, though, I mean, it was a co-director. You're now the director of the entire program?
No, right now I'm co-director with my with Dr. Fikret Isik. He's
Okay.
was my former PhD advisor, and he's been with the program for a long time. He's had tenure with the program, and like instrumental in coming up with the fourth cycle breeding strategy, testing strategy, and uh, part of the reason why the co-directorship was promoted is because I had to apply for my job. It wasn't I didn't just get hired into it, with the state funded professor position. And I didn't know if I was going to get it or not.
Mm.
It could have been given to someone from outside of our bubble, someone else in the community, or maybe even someone internationally. And that person would have a lot of power in the direction of the program.
Mm.
And I think our department head realized that, and to sort of try to tamp down any fears of somebody going off the deep end and trying to breed eucalyptus for the southeast or something
Right.
like that. Which this position has the power to do that if they wanted to. They might lose their funding next year, but
Right.
so she decided that why not have co-directors, that way they can kind of keep each other in check. And
Mm.
I'm excited. I am appreciative of it because I am new at this. I don't really know what I'm doing. I was great tinkering with
Mhm.
data sets in my closet, but now, leading and making strategy decisions is sort of scary. So it's nice that I can depend on my former advisor to
Mm.
debate these things, discuss these things, and come up with what we think is the best. And sure, we don't agree on everything. In fact, we disagree on a lot of things, but we always have really good debates, and they're
Mm.
they're thoughtful, they're objective, and
Mm.
they're always pushing us closer to the truth. And sometimes you think you have a good idea, and then your colleague reminds you that with facts that it's not as good of an idea as he thought it was.
Right. Yeah.
But, you know, peer review is a good thing.
Yeah, for sure. For some reason I had thought that he had retired and you had taken his place, but I guess I just misunderstood the whole relationship there.
No, in fact, we still have the previous director has been on board as our interim co-director, Dr. Steve McKeon, who is also on my PhD committee, because Ficret's coming back from a sabbatical.
Okay.
And so I will say we've had a lot of support from our department to make sure that this program doesn't crash. And so it may seem weird to have like 3 co-directors right now, but I mean, that's 3 folks that every day are working towards making the program better. So it's really exciting. It's a great group of people to work with.
That's awesome. I'm happy that you found a position that is very rewarding. And obviously, whenever you feel good in your job, it makes you want to do it better and better. Right?
Absolutely.
Yeah. Well,
and the converse is true too, you know,
right.
And I think that's why most people, make the decision to leave a job is because they're not doing a good job, or they're not happy about it. So they're not doing a good job, and it kind of builds on it. It turns into this mess, and you just got to break free from it.
Well, I wanted to talk to you a little bit about, since you do have the background in biometrics, one of the issues that we face is every year and every so many years, we got a new cycle of genetics coming through. And then the question always comes to me is, how are we incorporating genetics into our models?
Yeah.
And it's kind of, the question, the answer is usually it depends, like all things forestry, but the real answer is we're basically not. So there are different ways of incorporating quote unquote genetics, but they're not actually incorporating the growth patterns of those genetics. Because why? Because we don't know what the growth patterns of those genetics are. So while this is a little bit, I'm setting it up, it's a little bit of a loaded question, but I'm just curious into your insight into how we might start, and I've read some of your papers, how we might start putting genetics information into our models to get better results.
Yeah, it's a tough question,
right?
But we're not completely clueless, right? We know that they're trees. We have a lot of data on how trees grow,
right?
But we're changing these trees. We're changing the frequency of the genes that we like, and reducing the frequency of the genes we don't like. So we're altering them, and no, we haven't turned the wolf into a dog yet. But that's essentially what we're doing. So I think we really have to ask ourselves, okay, what are we selecting for? And if you're familiar with progeny testing, and probably one of the biggest disconnects between the forest geneticist and the forest biometrician and modeler is that when we make selections, we select individual trees. And we usually select them at young ages, about 4, 5, 6 years old. And the way that they're planted, in the forest that they're planted in, it's a mix of genotypes, and it's basically like a randomized complete block design, and each block, the treatment is the genotype, and you may have 100, 200 different different families in each block, and you're making decisions based on all those measurements. But at the end of the day, you're going to take one of those trees on to the next generation. So we're selecting individual trees. Well, when we plant trees, we plant forests. And so going from those individual tree young measurements to what's the impact we're making on our forest that we plant, grow, and harvest is a tough question. I think we have to ask, what are we selecting for? So we're selecting for fast growth, and we're selecting for big trees in a pre-competition, pre-stand closure environment. Does that mean that we're improving the carrying capacity of the forest that we're planting? Does it mean that we are not improving the carrying capacity. We're just improving the ability for those genotypes to fill in the site, to occupy the site. And I have done some lit review on silviculture treatment response models. And Burkhart and Tomei have a really good chapter on the subject. And they even put genetics in that chapter because it is a silviculture. Genetics is just the tool of the silviculturist. And you can look at some different treatment response functions, like a response to nitrogen fertilization. We tend to classify that as a response that doesn't change the carrying capacity of the site. It just increases the rate at which the site is occupied. So with repeated nitrogen fertilization in certain stands, you're not going to increase the total, the maximum stand density index or the total carrying capacity. Well, what you will do is you'll basically hit the fast forward button and reach that point in time sooner. So that maybe that's what we're doing when we select for fast growth. Another analogy would be on a deficient site for phosphorus, adding phosphorus fertilization, where there you're actually changing the carrying capacity. You're improving the site index. You're going to get more from that site than you would have otherwise. And maybe the genetics that we're selecting for, the genes that we're sampling, are associated with that type of response.
Right.
Maybe we're selecting some genes that are associated with the former and the latter. And so we just don't know.
Right.
And, we're never going to find out because of the problem that you mentioned. By the time we've made our selections, we can't wait around for that data we can't wait for the growth and yield type studies or else we'll always be behind. So that's what's tough for the biometricians. They're always looking in the rear view mirror, or
Right.
the geneticist is always looking in the rear view mirror to see what we've done in the past. So I do think, though, that we can start to characterize these things by looking at historical data. And the cooperative has a study where that is the objective of the study. That's the other thing is you have to have experiments that try to just focus on that one question. And what we're seeing is probably a little bit of an improvement in carrying capacity, site utilization, where it suggests that just adjusting site index will probably account for a lot of the variation in the gains that we're making from genetic selection. But we need some more data before we can say, all right, how good of a job does that do? What percent of the variation is not explained?
Yeah.
Those are some of that's an active, ongoing area of research.
I'm curious because you've mentioned this to me before, but we talk a lot about genetics, but there's also clones, and clones seem to work very well in something like eucalyptus. But based on our conversation, I get the feeling that clones and loblolly pine aren't necessarily as good as some of our better, actually selecting for genes, doing, MCPs or whatever. So can you talk a little bit about that? Why is clonals not as good as, in other species like eucalyptus?
Yeah. So, Mickey, the genes are important, right? But also propagation of the material is super important.
Okay.
And pine trees don't like to be cloned. They're not like willow trees where a stick off a willow tree will root on its own. And whereas eucalyptus, they're a lot more amenable to clonal propagation. We put in two clonal trials for our progeny testing, super useful for progeny testing. We put in 2 clonal trials over the last 2 years, and it's not something we'd done in a while. And it was really difficult just because they don't like to make roots. So that's the main thing that's holding us back is production of the material. Whereas a pine seed has the vigor to get going, and that's what Mother Nature, that's what natural selection did for it, as a shade intolerant species of wind dispersed seed. It from day one it just wants to go and get that primary foliage out, start making photosynthesizing on its own. And that's what you're up against. So that is why seedling production is going to be dominant for most pine species as well, especially in the South, especially loblolly pine in the South.
Yeah, that's interesting. Um, Another question I had was, there are some you can't talk forestry these days without mentioning carbon. So I have to ask a carbon question. So one of the things going on in the carbon world is just improving carbon storage. We see that, generation over generation, that our trees are at least weighing a little bit more, specific gravity's going up. Are there specific traits necessarily that you could select for that could improve like carbon storage at the individual tree level?
Absolutely. So the density of wood
Hmm.
is highly heritable. And what I mean by heritable is that if I choose a tree that has really dense wood and put it into my breeding program, or just collect seed from it, that's the way those seed perform is very much indicated by the way that their parent performed.
Hmm.
And wood density is very heritable, not just for loblolly pine, but for a lot of forestry species. And a lot of breeding programs do select for wood density. We don't. Um, in the Southeast, we don't have operational, or I don't want to say operational. As part of our breeding program, we measure wood density on our families, but we don't actively select for it. We don't actively breed for it. Some of our members do,
Hmm.
especially those that own their own sawmills.
Hmm.
But we don't do it because we're all growers, and it's the classic quantity versus quality.
Hmm.
We if you select for wood density and for growth, even though they're not negatively correlated, you're going to give up. The one that has the densest wood is only average for growth, and the one that's best for growth is only average for wood density. Just
Yeah.
quantitative genetics.
Yeah.
So that's why we don't. We focus on the growth, the straightness of the stem, and fusiform rust disease resistance. But if somebody knocked on my door and said, "Hey, we need to focus on wood density so we can get more carbon out of the air," I mean, we could answer that so well because those genes are in our population,
Hmm.
and they will respond towards selection. We use a drill. It's a precision drill that we put up against living trees in our progeny tests and drill through them. And what that machine measures is the resistance to the drilling motion. It's highly correlated um, with the density of the wood. Not for particular trees. If you just go up to a random tree and drill it, I can't tell you the density of that tree.
Hmm.
But if I have an experimental design like a progeny test, and I do 30 trees from this mother and then 30 trees from that mother with the drill, and then I rank them, it's going to be spot on for which families have higher density wood than other families.
Sounds like the perfect opportunity for a grant application. I'll give that one away for free.
Oh, absolutely. That's one that's been on my scratch pad. Is like, hey, federal government, you can make a big difference here. The market isn't going to be sensitive to this, just because of market dynamics,
Mhm.
but for the good of society, invest in this one, and it's going to pay off.
Yeah, but I mean, at least for now, we're seeing a lot of interest from the carbon world in, improved forest management. And I just have a wonder if, if we could find some way to reasonably model this, if giving up some growth for the alternative to have higher wood density for carbon capture storage, would that, would it work out at the end economically, given a certain price per ton, for carbon? So I don't know, but I've
It
just been
could.
curious about it.
It could. And that's why we have to have a diverse breeding population.
Yeah.
We I told you about the traits we select for, but we include a lot of trees. Some trees that are not a lot of trees that aren't the best for those because we may have to change tack in the future, and we need to have a diverse gene pool so we can do that.
Yeah, last question here for you. You know, the Forester's forecast, it's a bit of a play on words since we're biometricians and we're often forecasting. But I like to ask, you know, what is your forecast on the future of breeding? Are we going to continue kind of business as usual, or are there kind of like new pathways that you see it going?
Yeah, that's a good question. Because the business as usual is what turned wolves into dogs. The business as usual is what gave us corn from teosinte. It really works.
Mm-hmm.
But it took like 6,000 years for corn to be turned into teosinte to be turned into corn, and we can't wait that long.
Right.
So business as usual will definitely be a major part of it. But we have a lot of new technology like 23andMe type genotyping technologies that can help us do that job better.
Mm-hmm.
One thing that would really help us is if we're planting more tests, getting more data, getting better data, thinking about how we can incorporate some remote sensing and drone imagery. And other programs are doing this, at least at a research scale. We just gotta keep on doing what we've been doing, which is trying to figure out how to solve these problems and make things a little bit more efficient. And I don't think that it's an exciting answer. It's just keep doing what we've been doing, trying to solve little problems with new methods, new technologies, and just getting a little bit better at what we've been doing.
Yeah.
But always just getting a little bit better at what we've been doing.
And that's what we should all strive to do. And I think that's a great note to end on. Thank you so much for the conversation, and thank you everybody for listening.
Thanks a lot, Mickey.